Okay, we're going to talk about circumference, area, and volume. So just a quick reminder, the circumference of a circle is the distance around a circle. Okay, so the outer edge here, the distance around it. The formula for circumference, if you can't recall that, is the circumference is equal to the pi times the diameter. Or, since there's two radii in the diameter, its circumference is equal to 2 pi r. All right? So if you know the radius, or if you know the diameter, either one, you can find the circumference of the circle, the distance around the circle. Okay? An arc length, well, an arc length is a portion of the circumference. Okay, so rather than having the whole distance around the circle, we're going to take just a piece of that. So for instance, if I were to label my circle, let's call it circle P, and we'll label this point A and this point B, and I want to know the arc length of AB. So I'm not talking about a degree measure, I'm talking about a length. Okay, then I could say the arc length, which we would call in this case AB, is to 2 pi r, which is the circumference, as the measure of our arc AB. So let's say I were to call this measure right here, say 60 degrees. That measure is to 360. So let me explain what's happening here. You're saying the length of this arc is to the entire length of the circle, as the measure of this arc is to the entire measure of the circle. Okay, so it's like a part-whole relationship. This is a part, and this is a part. Or excuse me, this is a hole down here. It's kind of a part-whole thing. Okay, the top part would be dealing with a portion of the circle. So that would be the part. And the bottom part here would be dealing with the whole circle. That would be the whole. In one you're dealing with length, and the other you're dealing with angle measure. So if we were to simplify this and say, okay, I just want AB. Okay, well, if I just want AB, I'd multiply both sides of this by 2 pi r. So I'd find that arc AB, the length of that arc, is equal to the measure of AB, so the measure of angle or arc AB over 360 times 2 pi radius. Okay? So really I just want to know this chunk. So for instance, in this picture right here, I could say, well, the length of AB, if I were to actually work this problem out, the length of AB is equal to 60 over 360. So notice when I do 60 over 360, I'm actually dealing with 1/6 of the circle, if that reduces. So 1/6 of the circumference. Well, the circumference is 2 pi, and let's go ahead and give this a measure. Let's say it's 3. It would be 2 times pi times 3. Okay, so that would be equal to 1/6 of 6 pi. So in this case, it would just be 1/6 of 6 is pi. Now it's not going to always equal pi. That's just something I came up with off the top of my head, but that's how you do it. Okay, we're just finding out 1/6 of the circumference because 60 over 360 is 1/6. Okay, so let's apply this in some others here. So find the indicated measure of the circle, record your solution in terms of pi, and round it to the nearest tenth. So when it says in terms of pi, that just means pi is in your answer. You don't calculate it out. I'll show you when we do this. So circumference of a circle is what we're trying to find with a diameter of 6 inches. Okay, well, circumference we know is equal to pi d. If the diameter is 6, just circumference is equal to pi times 6. Also known as, we usually write it as 6 pi. Okay, so that's my answer in terms of pi. Now, rounded to the nearest tenth, I actually have to calculate 6 times pi. So circumference is approximately, when we round to the nearest tenth, 6 times pi is 18.85. And both of those, by the way, are measured in inches because we're dealing with inches there. So there we got it. Okay. And you can estimate, see if you're right. 6 times pi is 3.14. 6 times 3 is 18. It's 18.85, so we're good. All right, the diameter of a circle with a circumference of 15 centimeters. So find the diameter of the circle. I could use the same formula, c equals pi d. It's just this time I don't know the diameter, but I do know the circumference. So we substitute that in for c equals pi times diameter. So the diameter is equal to 15 over d. Or excuse me, 15 over pi, not d. So that's my answer in terms of pi. And once again, that's centimeters this time. So really, I guess I should write that there. 15 pi centimeters. That's my answer in terms of pi. And then if I were to round that, d is approximately, well, 15 divided by 3 is about 5. And in fact, 15 divided by pi is 4.77 centimeters, rounded to the nearest hundredth. All right, a quick side note. The circumference is equal to pi times the diameter. What I could do is divide both sides by pi, or excuse me, by the diameter, and get pi by itself. And that would tell me what pi is equal to. In terms of a circle, pi is equal to the circumference divided by the diameter. And that is true in any circle. Okay? That's how we get pi. We divide the circumference by the diameter, and that gives us the value of pi. It's that ratio. Okay, let's go ahead and find some arc length. So find the indicated measure of each circle, round your answer to the nearest tenth. So we're finding the arc length of EF. So EF is equal to, remember a formula, it's your measure of arc EF over 360 times 2 pi r. Okay? So make sure the measure, and then without the measure, it's just the length. So in this case, we substitute our values in. Okay, well, measure of EF is 55 over 360 times 2 pi, and the radius is 2. So really that's 55 3/60ths. I'm going to reduce that. Okay, that becomes 11 over 72. I know we don't really have to do that, but I'm going to try to make a point here. 11 over 72 times 2 times 2 times pi is 4 pi. Okay, that means I have 44 over 72, okay, which once again, we can reduce that. I'm going to go ahead and block this off here. I'm going to reduce that to, well, what comes out of both of those? I think 4 does here. An 11, I guess I could have cross-canceled up there. And 4 goes into 72. A grand total of 18 times 11/18 pi. That is my answer in terms of pi. Now it says round to the nearest tenth, so you don't have to do that, but you're going to see in a minute we actually keep things in terms of pi when we're dealing with radians, so I wanted to show that there, how we could reduce. Anyway, that's 0.61 times 3.14, which gives me 1.9-ish. And that's in inches. All right. Notice we switch it up on part B. We actually want to find the circumference of the circle. Okay, so let's go ahead and change up our color here. And so we're using the same formula, however. So in this case, arc CB is equal to the measure of arc CB over 360. And we usually say times 2 pi r. However, since we're looking for the circumference, well, 2 pi r means circumference, so I'm just going to leave that as c. Okay, c being the circumference. So substituting in what we know arc CB is 5. We know the measure of CB is 117. And we're trying to find the circumference. Okay, well, to solve that, multiply by the reciprocal here. Okay, so we multiply both sides by 360 over 117. Okay, so using your algebra skills there, okay, notice this cancels this cancels this. We're left with C, and 360 divided by 117 times phi. Well, if we actually did the math there, 360 times 5 is 1,800. So it's 1,800 over 117. And when we do that, we actually get the circumference is equal to 15.4 centimeters. Now you'll notice I keep doing a bunch of this fraction work here. Okay. In fact, on that one, when I did that, I could have divided them both by 3, right? I could have reduced this to 600 and this to 39, and I could have even went further, right? I could have went down to 200 and down to 13. Okay. However, I stopped reducing there and I just left it as 1,800 over 117. But the reality is when we do these next couple problems here, once we get to radians, you're going to want to be able to deal with those fractions. So I'm trying to give you a little fraction work in between here. Okay, so find the measure of LK. So this time we're not finding the arc length like we did in the first one, or the circumference like we did in the second. This one we're actually finding the measure of the angle. So we use the same formula though. We know the arc length KL, or LK, since that's what we are given there, is equal to the measure of arc LK over 360 times the circumference, or 2 pi r. And then LK, the measure of it, is 10 feet. And that's equal to, or excuse me, the length of it is 10 feet. That's equal to the measure of LK times, or over 360, times 2 times pi times the radius, which is 7. So we get 10 is equal to MLK over 360 times 14 pi. Multiply both sides by that 360 to get that out there. So we'll go 300, or 3,600 is equal to measure of arc LK times 14 pi. And then divide by that 14 pi to get 3,600 over 14 pi equals the measure of arc LK, which when you do the math there, that is 81.9 degrees approximately, when we round to the nearest tenth, is the measure of LK. All right. Let's try one more dealing with arc length here. So the diameter of a bike tire is 28 inches. To the nearest inch, how far does a tire travel after 150 or 125 revolutions? So we know that the distance traveled is going to be equal to 125 revolutions times whatever the circumference of a tire is, right? So if I'm starting right here and I rotate around once, there's 1 revolution, 2, 3, and so on, right? I keep tracing that circumference over and over, so it's 125 times the circumference. Okay, so really what that means is I'm going 125 times, well, the circumference is pi d. They tell us the diameter, so we'll use that. That's going to be 125 times pi times the diameter, which is 28. Okay, and 125 times 28, well, that gives us 3,500. So we have, in terms of pi, it's 3,500 pi, which if we do the math there, that is 10,996 inches. That's how far it travels. Okay. So now kind of what I've been talking about this whole lesson is dealing with radians here. So the reason we use this hopefully will be clear after I discuss what a radian is. Okay? So there are two ways that you'll measure angles generally in high school. One is degrees, the other is radians. You've spent the whole time dealing with degrees. A radian is the measure of an angle in standard position. Okay, let's stop right there for a minute. In standard position, that means if I have a circle with an XY coordinate plane here, and if I take and set like an arm that goes, or a ray that goes from the center of the circle out on the x-axis, that is called standard position. And you'll talk more about this when you start studying trigonometry, but I'm going to use the same terminology right now. Okay, so standard position, whose terminal side, well, that means I start rotating this angle. And if I have a terminal side, that means an ending side of the angle. So that would be my terminal side here. You know, let's switch up colors for the sweep of the angle there. Okay, so there's my terminal side. So we've taken this angle, we've rotated it a certain amount here to a terminal side. Okay, well, we know this angle length here. Okay, or excuse me, we know of this right here we're going to call r. It's a radius, as is this. This is a radius. Okay, so the measure of an angle in standard position whose terminal side, right, of an arc, or intercepts an arc. So here's the arc. It intercepts that arc. That is the same length. Now, no, we're dealing with length, not measure. The same length as the radius of the circle. So in other words, if I were able to trace out this radius with a string, the length of this radius, and then cut that string off and lay that string right here along the edge of the circle, that is 1 radian. A radius that is lying on the edge of the circle, if you're able to bend it, okay, and arc it along the circle, that is called 1 radian. Okay? All right. So what we have is we have a circumference of a circle. Let's kind of tie this together. The circumference of the circle we know is equal to 2 pi r, which means if I want to know, the question that I would have in class is, how many radii are in a circumference of a circle? So radii are plural for radius. Are in the circumference of a circle. So we mess around with that a bit, but hopefully you would take the circumference. You could pause it and try it here, but you take the circumference, and if you want to know how many radii fit into a circumference, hopefully you take that and divide it by r, if you want to know how many go into it. And what I hope you find out is, note that the r's cancel, and you find that in any circle there are 2 pi radiuses in a circumference. In other words, we call a radius that's on the outside a radian, so there are 2 pi radians in an entire circle. Which means in 360 degrees, because that is an entire circle, there are 2 pi radians, or 2 pi radiuses. Okay, so just over, well, pi is 3.14, so 2 times 3.14 is 6.28-ish. So there are just over 6 radiuses that will fit along the outer edge of any circle. If you don't believe me, try it. Take a circle, cut it out, and, you know, measure your radius and try to lay it along the edge. You'll get just over 6 of them. And if 360 degrees is equal to 2 pi radians, then half of that 360, which is 180, 180 is equal to half of 2 pi, which is pi. So 180 degrees has pi radians. 360 has 2 pi radians. you go from here to here, you've traveled pi radians, or just over 3 radians. From here, to here, you've now traveled 2 pi radians, or just over 6 radians. Okay, so how are we going to use this? Well, in Algebra 2 and trigonometry, you're going to use it quite a bit, well in pre-calculus and calculus, but what we're going to do with it is we're going to use this ratio right here, or we're going to make a ratio out of that, pi to 180, okay, comparing radians and degrees here. So you're comparing radians and degrees by using this ratio. We're going to use that to actually convert between radians and degrees. So to convert between degrees and radians, we want to use the ratio pi over 180. I guess you could use 2 pi over 360, but if we use 2 pi over 360, note we just cancel the 2, call it 1, change that to 180, and you get pi over 180. So that's why we use pi over 180. Okay? So how do we do that? Well, if I'm converting my degree measures to radians and my radians to degrees, I'm going to just start by writing my ratio, pi over 180. I know that's the ratio. And that is going to be equal to, well, now we're going to have a proportion where they're giving us the degrees. So notice degrees are on the bottom here, so we have to put the 60 down here, and radians are on the top. So we're trying to find R. How do we solve a proportion? Well, you cross multiply. 60 times pi is equal to 180R. Now, if I want to solve for R so I know how many radians, I divide both sides by 180. So I get 60 pi divided by 180. Well, note, remember what I've been talking about all lesson is that we want to make sure we leave it in terms of pi, because now we're in radians. So you have to reduce this. Well, what goes into 60 and 180? Well, 60 does. 60 goes into 60 once, into 180 3 times. So the way we write that answer is the radians is equal to 1 pi over 3. That's how many radians there are. Radians we generally leave in terms of pi. So there are pi over 3 radians. Now if you think through that intuitively, just kind of thinking through it, if pi is 180 degrees, then 60 is a third of 180. So if 60 is a third of 180, like if we divided this by 3 to get 60, we'd have to divide this by 3 to get pi over 3. That would be the same thing. That's what we're doing here. But we just did it in a way that we can show, or a way we can do all of these. Okay, but as you move through this into algebra, or into Algebra 2 and trigonometry and calculus, you'll start doing things more intuitively in your head. Okay? And if you want to try it now, just kind of challenge yourself a bit. So here we go. We got negative 135 degrees. So in my class today, I had students saying, well, how can you have a negative angle? That just means back here at our circle, rather than going counterclockwise, you actually go clockwise. So you go downward. That would give you that negative angle. Okay? But negative 135, so we're comparing radians over degrees. So we'll replace the degree with negative 135. Okay? Well, we go through the same process. We're going to go ahead and cross multiply. So we get negative 135 pi is equal to 180R. To get R by itself, divide by 180, so you get R is equal to negative 135 pi over 180. If we reduce that, you can go through multiple processes, divide by 5, then divide by 9, or I recognize 135 and 180, actually 45 goes into 135 3 times. 45 goes into 180 4 times. So this is negative 3 pi divided by 4. That is the radian. By the way, if you didn't recognize that and you're going negative 135 over 180, you could have divided by 5 first. Okay? That would have given you 30, divided by 5 here. And got it? Oh, yep. Okay, negative 27 here and 36 here. And then hopefully you would have recognized, well, I could take a 9 out of that 3 times and 4 times. So if you didn't recognize 45, you just keep reducing. Okay, well, let's go the other way now. Let's go ahead and convert from radians to degrees. So we use the same ratio. It's just rather than having r over d and replacing d, we're now going to replace r. We're going to replace it with pi over 8. Now that looks a little weird, so up here I'm just going to show something. If I take pi over 8 and I divide it by d, that is the same thing as taking pi over 8 and multiplying it by the reciprocal of d, or 1 over d, right? We don't divide, usually we multiply by the reciprocal, which actually gives me, well, pi on top and 8d on bottom. So whenever you have a compound fraction like this, you could just take this 8 and move it down, or whatever number's there. So you could have pi over 180 is equal to pi over 8d. Notice the numerators are the same, so really the only thing you have to worry about are the denominators here. You need to set 180 equal to 8d, because the numerators are already equal. So if you get the denominators equal, you're good. How do we do that? Well, we divide both sides by 8, so we get 180 over 8, which, by the way, is equal to 22.5 degrees. Make sure you put the degree symbol. All right. We got 2 more here. First one, we set it up. Pi over 180 is equal to r over d. We're going to replace r with 3 pi over 4. And then remember, we can rewrite this and move that 4 down, right? So we could write it as pi over 180 is equal to 3 pi over 4d. Well, neither numerator or denominator are the same, so to solve, we're going to cross multiply. Okay, so let's switch up our colors here. So we got 4 times pi times d is equal to 180 times 3 is 540 times pi. Divide both sides. Okay, so we're going to divide by 4 pi, and that's going to cancel. Going to be left with d. And divide this by 4 pi. Pi's will cancel. 540 divided by 4 is 135 degrees. Now, some of you may have recognized right away, like, hey, hold on. If this problem right here, if negative 135 was negative 3 pi over 4, wouldn't positive 3 pi over 4 be positive 135? And the answer is yes, it would. All right, one left. If you've been practicing doing these intuitively, then you might know the answer to pi over 6. Remember, if pi equals 180, then, well, what if I divide this by 6? That would mean I divide this by 6, right? So pi over 6 is actually 180 over 6, which is, well, 180 over 6 is 30 degrees. And you're like, well, what about the negative? Well, just make each of them negative. So it's negative 30 degrees. Okay, now if you're like, whoa, that kind of was messed up there. I don't know what he did. Well, just set up your ratio then. It's okay to do it that way. I'm just trying to get you to think another way as well. So that's r over d. And we replace r with negative pi over 6. And then remember, we can move that 6 down, right? So it's pi over 180 is equal to negative pi over 6d. Well, remember what I said on this one. The tops were the same. The numerators were the same, so we just had to compare the denominators. Well, here the numerators are almost the same if we wouldn't have this negative. Well, the negative's kind of a floating negative. It could go with the pi or the 6. So if we wanted to, we could have moved it down there with it and got rid of it there. So now they are the same. So really all you have to compare, once again, is the denominators. So 180 equals negative 6d. Divide both sides by negative 6. So d is equal to negative 30. All right. Well, that's all I got for you. Good lucky.